Good day again to everyone. Welcome back to our channel. Okay, so before we're going to start our lesson regarding the derivative as the slope of the tangent line, now may I encourage and seek your support by supporting this channel and by clicking the subscribe button and the notification bell so that should there be any lesson that will be posted in the future, you will be notified. Okay, so again, thank you for watching this video, the previous videos, and advance thank you to those who will be watching the future videos that will be posted. Okay, so our focus today is the derivative as the slope of the tangent line. Notice that before we're going to discuss this one or focus our attention with regard to the slope of the tangent line, now there are things that we need to define, or may I just share some of the definition of terms that we need to define or understand. Now the first term is differential calculus. Okay, now what is meant by differential calculus? Now the meaning of differential calculus is actually the study or the branch of mathematics that study the derivative. Okay, so again, differential calculus is a branch of mathematics that deals with the study of derivatives. So that is the very simple definition of differential calculus. Now another one is our focus. So the next term that we are going to define is what is meant by derivatives. So we have in here the meaning, the derivative. Okay, now how do we define this one? Now we define this one according to how it is being used. For instance, my definition in here is it is an instantaneous rate of change, meaning to say it is a rate of change at a certain point, at a certain moment, or within a given moment. So the very good example of this one is speed. So we have what we call the instantaneous speed. Now what is that? What is the meaning of instantaneous speed? It pertains actually to a speed to a given or a specific time. Okay, so what is the speed of a traveling object or a motion at a very specific time? So that is the meaning of instantaneous. Now another one could be defined as it is the slope of the tangent line. Now in a while we will be discussing the meaning of the slope of the tangent line. Okay, now another meaning is the limit of the difference quotient, okay, of the slope of the tangent line. Okay, so these are the simple definition of the derivatives. Okay, these are the simple definition of the derivatives. Another term that we need to understand is the meaning of differentiation. Okay, now what is the meaning of differentiation? Okay, now meaning to say, when we say differentiation, it is actually the process of computing the derivative. Okay, it is actually the process, the method, or the ways on how we calculate derivatives of a given problem. Okay, so those are the simple or the terms, the basic terms that we need to understand. So differential calculus, derivative, and differentiation. Okay, so those are the things that I would like to share. Now our focus now is to find the slope of the tangent line. Okay, find the slope of the tangent line, so that before we're going to look into the slope of the tangent line, now, of course, we have to understand what is the meaning of the tangent line. Okay, what is the meaning of the tangent line? So when we are going to define the meaning or define the tangent line, it is actually a line. Okay, It is actually a line. A line that touches, okay? That touches a circle, okay? A circle or a curve at exactly, okay, at exactly 1 point, on the circle, okay, on the circle or the curve, okay, or the curve. So that is the meaning of the that is the meaning of the tangent line. So when we say tangent line, it is actually a line that touches, okay, a line that touches a point on a given curve or a circle. Again, at exactly 1 point, okay? Where is the point located? Located on the circle or on the curve. So that is the meaning of the tangent line. Now, to illustrate this one, now allow me to show this simple illustration having the curve on the Cartesian plane. So notice that I have in here a Cartesian plane and of course a curve with color green. Now notice that when I'll be locating 2 points on a curve, notice that when I will be connecting this one, definitely it will create a line, okay? It will create a line. So if I were to connect this one, definitely what is created is actually a line, okay? Now, so that you will notice that the line that I created by connecting the 2 points is not a tangent line, okay? It is not a tangent line because as we define the tangent line, it is a line that touches a circle or a curve at exactly 1 point. But notice this one, the line touches 2 points at exactly 1 point. Then what is this kind of line? Okay, the point is, what is that kind of line? So that is called to be now the, okay, this is called to be now the secant line, okay, secant line. So when we say secant line, it will be the opposite of the tangent line. Now, how is that? The secant line is a line that connect 2 points, okay, exactly 2 points on the given curve or a circle, okay. So again, a secant line is a line that connects two points on a given curve or a circle. So I have in here a line that is called to be the secant line. Now the point in here is when we are going to get the slope, of a line, now basically we always consider, okay, 2 points. So 2 points on a line. So that notice that my 2 points on a given line is also point on a circle, okay. So allow me to have this one, have the first one to be my point 1, okay. This will be my point 1, okay. So what is my point 1? Should I say this is x, okay, and should I say this is x? Now the question is, what is the coordinate of point 1, okay. Now notice that when we recall the meaning of the function, The function f of x is always equated to y, or in another explanation, y is always dependent on x. So that when we are going to look for the coordinates of the point 1, now we say that if our x is, if the first calibration is labeled as x, then because your y is dependent on x, then this first calibration I have in here could be said to be the f of x. Okay, so why? Because as I said, when we are going to look for the value of y, your y is defined to be f of x. And so what is our first calibration? That is the value of x. We just make use of the letter x. So by substituting that one, that is the same as x. And so having said that one, then we can have now the coordinate of this one to be what? To be x and f of x. So that is the coordinate of the first point. Okay, that is the coordinate of the first point. Now the question is, what about this one? If that is point 1, then this must be point 2. The question in here is, what is the coordinate, or what are the coordinates of this point 2? Okay, so what are the coordinates of the point 2? Now to name the coordinates of the point 2, we have to remember that this one, okay, we have to remember in the graph that when we are going to have this point, okay, now let's try to allow me to have this illustration. Notice that when I'm going to have my slope in the previous discussion, from this point going in here is actually, now we define this one to be the change of, what is that? We define this one to be the change of x, and the same as this one to be the change of y. Okay, so that if this is from this point going to this point, which correspond to your point and this one, now we can now have the second calibration to be what? What would be the second calibration? This one. So this must be the addition of x plus change of x. So that is x plus the change of x, meaning to say this is your x from this point, your x which is from this point, and your change of x is from this point. So if we are going to add that one, then this calibration is x plus change of x. Now having said that one, we can have now the coordinate of this point 2. Now what is the coordinate of the point 2? Allow me to make use of a green ball pen. So the value of x is x plus change of x. Okay, so what about the y? In here? Remember again that when we have the y, our y is dependent on the x. Okay, dependent on the x. So meaning, if my x is x plus change of x, then this must be, again, so if my x is equal to x plus change of x for our point 2, then this must be, what is that? F of, okay, replace that one, that is x plus change of x, and change of x. So with that, if this is f of x plus change of x. Then my point in here in the point 2, the coordinates are x plus change of x, and what is that? f of x plus change of x. So that must be my point 2. So again, my point 1 is defined to be x plus f of x, which is this one. Point 1 is x and f of x. Point 2 is x plus change of x and f of x plus change of x. So that is my point 2. That is the same as we just follow. Okay, we just follow the point. So what is the point? The point is actually, if that is point 2, we say that our point 2 is actually x sub 2 and then y sub 2. We follow this one. Okay, we follow this one. So what is your x sub 2? So that is your first x, that is your second x. So this must be your x sub 2, x plus change of x, which is this one. And what about your y? Your y is f of x plus change of x, which is your y sub 2. The same as in here. For our point 1, that is actually, it follows the x sub 1 and y sub 1. So that is our point. Okay. Now, having said that one, there's a time now we can have the slope of this second line. So that you notice that when we are going to get the slope of this second line, it is not actually the slope of the curve, but it is the slope of this second line. But remember, when we are going to get the slope of the second line, now we have to go back with the meaning of the slope. That when we say slope, our slope is actually defined to be the change of y over change of x, or that is the same as y sub 2 minus y sub 1 over, that is the same as x sub 2 minus x sub 1. Now before we continue this one, now the change of y over the change of x in here now is actually the definition of the derivative, which is the same as the change of rate. Okay, that pertains to the change of rate. Now notice that when we are going now to continue having the slope of the second line, okay, let's try to have the slope of the second line. Now we say that m, okay, sub secant, okay, slope of the second line. So that you will notice that when we are going to get the slope of the second line in here, now our second line is this one and defined by at least 2 points, so that our y sub 1 will be our f of x plus change of x. Okay, so ayan. So let's allow me to make use of another color so that at least you can see them. So our y sub 1 in here is actually f of x plus change of x. So that is the same as f of x plus change of x. Okay. Now, what about our y1? Our y1 is located at point 1, which is the same as y1 is actually f of x. So that is the same as minus f of x. Okay. Now, what about the x sub 2? our x sub 2 is actually x plus change of x. So that is the same as x plus change of x. Now what about the x sub 1? Our x sub 1 in here is the same as x. So as you can see in here, using our illustration, that is the same as just x. Okay? So the slope of the second line is the quotient of f of x plus change of x minus f of x over x plus change of x minus x. Notice that when we are going to continue that one, the slope of the second line will give you a result of, f of x plus change of x minus f of x. Now what about the denominator? Notice that the denominator we have in here x and x, they are opposite, so that if you're going to subtract them, it will give you 0. Now what remains now in the denominator is change of x. Okay, so change of x. Now so that you will notice when we are going to look into the one of the definition of the derivatives, the slope of the second line, which is the quotient of f of x plus change of x minus f of x over change of x, is the same as this one. Okay, it's the same as this one, the limit of the difference quotient. So that when we are going to get the limit of this one as your x is approaching 0, that is actually the definition of the derivative. So let's try to have now, so that this form in here can be written also in limit form. So we can have that one to be the limit. Okay, the limit as your change of x approaches 0 of, we have in here, okay, f of x plus change of x minus f of x over change of x. So this one is actually now the one of the definition. Okay, this one is actually definition of the derivatives. Okay, let's try to underline. Okay, it's one of the definition of the derivatives. Okay, or this can also be equated to what? Equated to the slope, or because we are talking of the derivative, this can also be f prime of x. Okay, these are the notation of derivatives. Or this can also be d over dx. Okay, so d over dx is the same as f prime of x, is the same as the slope, is the same as the limit of f of x plus change of x minus f of x over change of x, as x change of x is approaching 0. So they are all the same. So meaning to say, using the other notation, okay, using this notation or this one, are all indication that they pertains to derivatives. Okay, now so that you will notice when we are going to get the limit of the slope. Now the limit now of the slope is this form now. is also called to be the slope. Okay, slope, slope of the tangent line. Tangent line. Okay, these are also be the slope of the tangent line. Now, how come that is the slope of the tangent line? You will notice that when we are going to illustrate this one using our drawing, now notice that this is actually derived from the slope of the second line. But notice that when the second line will tilt down, okay, it will move down, okay, it will be pulled down, and so that if it will be pulled down, you notice, you will observe that it has this effect. Let's try to have. Notice that when you will be having now the movement, still this line touches point 1. So that if this is point 1, point 2, the second line is can be labeled as line 1. Now, so that when we will be pulling that down, more or less we say that this must be line 2. Now, notice that the line 2 still touches 2 points on the curve. So it touches point 1, and let's say this, if this is point 2, this must be point 3. Meaning to say, if the line 2 touches the point 1 and point 3, now still this is line 2 is still a second line. But notice at one point, when this one will continue, the line 2 will continue to be tilting downward, there will be a point, or there will be a chance, or shall we say a scenario, that it will just only be, okay, there will be a chance that it will just only be touching. Okay, so the line 3, shall I say, I will say that this must be line 3. I will make use of the another color, so that you will notice for the line 3 that you will notice it will only be touching what? It will only be touching point 1. Okay, it will only be touching point 1. So notice that when it will only be touching point 1, then we can say now that your line 3, okay, line 3 is considered to be what? A tangent line. Okay, so this is considered now to be tangent line. Why? Because it only touch 1 point on the curve. Okay, so if that is a tangent line, then our point 1 now in here, in relation to line 3, then this must be called to be the point of, okay, point of tangency. This must be called to be now the point of tangency. So that if we consider this one to be the slope of the tangent line, now this tangent line now has, now this tangent line now, the slope of this tangent line now, so if we consider this slope or limit as your x is approaching 0 of f of x plus change of x minus f of x over change of x to be the slope of the tangent line, now it will follow that this must be the slope of the curve. It must be the slope of the curve on that certain point called to be point of tangency. So I repeat, if the limit of f of x plus change of x minus f of x over change of x as your change of x is approaching 0 is called to be the slope of tangent line, okay, the slope of tangent line, then it follows that this must be the slope of the curve on that certain point, okay, called tangent line. So meaning to say, if we go back with our definition, slope of tangent line, the derivative is the slope of tangent line. The point of tangency is the slope of, it is the slope of what? Okay, it is the slope of the curve. So the slope of the line is considered to be the slope of the curve on that certain point called point of tangency. So again, the slope of the tangent line is also the slope of the curve on that certain point called point of tangency, okay, called point of tangency. So meaning to say, whatever derived, computed, calculated slope in here will be the slope of the curve on that point of tangency or on that certain point. So I hope you got the I hope that you understand the method of deriving the slope of the tangent line. Okay, so the process of taking the slope of the tangent line is called to be differentiation. Okay, so it is called to be the differentiation. Why? It is a process. So the method that we use in here is differentiation to solve for the slope of the tangent line. Okay, so let's try to see some of the example. Okay, let's try to see some of the example. Now we have in here an illustrative example. So it says in here, find the slope of the tangent line to the graph of the function f of x, which is defined to be x raised to 2 plus 1 at point -1 and -2. So meaning to say, if we are talking of the tangent line, then this point must be considered to be the point of tangency. Okay, point of tangency. Now, before we're going to solve for the slope of the tangent line, okay, tangent line that is touching the function or the quadratic function f of x is equal to x raised to 2 plus 1. Now we have to graph this function, okay? So that if we are going to graph this function, now we have to consider that there is no restriction with the domain. So the domain of this function are all real number. So what about if we consider the possible values of x, okay, starting with positive 3 down to negative 3. So these are my values of x dictated by the domain. Okay, definitely it includes negative 4, negative 5, negative 6, and so on and so forth. Or it will also include 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Now considering this one, so that we are going to graph, okay, we'll see the graph of this one. Now let's try to see the result of f of x if your x is 3. So that if your x is 3, that is 3 raised to 2, that is 9 plus 1, that is 10. So meaning to say, this must be 10. If your x is 2, then that is 2 raised to 2 is 4 plus 1, that must be 5. Okay? If that is 1, your x is 1, that is 1 raised to 2 plus 1, that is 2. Okay? And of course, if your x is 0, 0 plus 1, that is 1. The same as if your x is negative 1, negative 1 raised to 2 is positive 1 plus 1. Still, that is the same as 2. Again, what about if your x is negative 2? Negative 2 raised to 2 is the same as positive 4 plus 1. That is 5. Okay? And if that is your x is negative 3, negative 3 raised to 2 plus 1, and that must be 10. Now, having said that one, now we can now see the graph or the orientation of the graph that we will be having. Okay? So, to graph that one, definitely, let's try to at least make use of a ruler so that at least we have an accurate graph. So our x is 3, okay? So this must be positive 3, so located in here. Now, where must be the 10? So 10, that is located in here at least. Ayan. So we have in here the point. Now, if our x is 2, and if our x is 2, where must be the point located? The point located must be located in here. So that is the same as 5. Okay? Yeah. So this must be our point. And if that is 1, definitely, if that is 1, the result will be 2. Okay? Result will be, your y must be 2. Your y will be 2. So we have in here. And of course, if that is 0, your x is 0, your y must be 1. So meaning to say, it is in here. So that is the intersection or the intercept. And if that is negative 1, it will follow that your y must be again 2. Okay? Yeah. And if that is negative 2, it will follow that that must be positive 5. So positive 5. So yeah, that must be our point. And if that is negative 3, it follows that your y must be 10. So meaning to say, more or less, that is how it is located. Okay? So these are the points. These are the points. These are the points on the parabola. Okay? So that if we are going to have the graph, okay, let's try to have the graph. Okay, so when we are going to have the graph, that is parabola. Okay, that is parabola. Okay. Okay, so that is the graph of the parabola that we have. So notice that before we move on, now let's try to name this one. So what is the name of our parabola? The name of our parabola is name as what? F of x is equal to x raised to 2 plus 1. Okay, now it says in here, the point of tangency is defined by negative 1 and 2. And so where is that one? Point of tangency is defined by negative 1, which is your x, and positive 2, your y, which is 2. So the point of tangency, if we are going to have that one, is actually in here. Okay, the tangent line that we have, may we make use of green, we have this one. So that is the point of tangency. Okay? So that is the point, that is the tangent line. So where is the point of tangency? The point of tangency, allow me to label this one. Okay? So that is the point of tangency. Yan. So what is the point of tangency? The negative 1 and positive 2. Now, after knowing now the point of tangency and tangent line, so this is our tangent line, now we are ready now to solve for the slope. Okay? Solve for the slope. So that when we are going to solve for the slope, we have to recall our limit or the definition of the derivative. And we have the limit as your change of x is approaching 0 of, what is that? That is the same as f of x plus change of x minus f of x, okay, over the change of x. Now, remember that our function is we have in here. So meaning to say, if our function is f of x is equal to x raised to 2 plus 1, then we can substitute this one. Okay, so we can have the statement, we can have now the statement, the limit, okay, the limit of what is this? That is the same as x raised to 2 plus 1, okay, minus x raised to 2 plus 1. Of course, as your x is approaching, as your change of x is approaching 0. Now, let's try to have, I try to make use of the function so that you will notice the value of my x in here, according to our limit notation is x plus change of x. So that with that we can have now this statement, this one, replace this x raised to 2 with this statement, that is the same as x plus change of x, and that is raised to 2, definitely with plus 1, okay, that is plus 1. And what about this part? Okay, what about this part? Definitely, what is the value of x in here? X raised to 2, we have in here x, just x. So we can say that is minus x, just the same, x raised to 2 plus 1. You might be saying, why did not it change? Now notice that I repeat, the value of x, the x in here, the second function in here is this one. Okay, the value of x raised to 2 in here is this one, the x. Okay, so can I make this one to be illustrated properly? Yeah. Okay, so notice that I just replace, okay, definitely that is over change of x, and again that is the limit. Okay, limit as your change of x is approaching 0. Okay, approaching 0. Now, considering that you have to expand that one, okay, considering that you have to expand, let's try to expand now. Okay, I will make use of this one now. Okay, so x raised to 2, that is the same as x raised to 2. Okay, x multiplied by change of x, that is the same as change of x and the x, then 2. Okay, so that is 2 x change of x. Now, change of x raised to 2, that is the same as plus change of x raised to 2 plus 1. Okay, so that is the expanded. Now, what about this one? Distribute, so it will give you negative x raised to 2, negative 1. Definitely that is over change of x. And of course, we are still having the limit notation in here, limit of the function as your change of x is approaching 0. Okay, now notice that if we are going to simplify, this one is opposite with this. Okay, so that must be 0. How about in here? This one is opposite, negative 1. This is positive 1. Is 0, result again to 0. So we have now a result. Okay, we have now a result that is the same as 2x change of x plus change of x raised to 2 over the change of x. Definitely still we have the notation of limit. We did not yet use the limit. Okay, so still included change of x as it approaches 0. Now notice in here that there is a common factor. What is the common factor? The common factor is this one. Okay, common factor. So if that is the common factor, then we can factor out. So what is that? We have now change of x, okay, multiplied by 2x. What is left in here? Plus change of x. Okay, and then over change of x. Definitely still that is the same as the limit as your change of x is approaching 0. Notice that we can now make a cancellation in here. We can now cancel out this one. So what remains now is the limit as your change of x is approaching 0 is equal to is 2x plus change of x, okay, over 1. Or that is the same as when we are going to simplify now. When we are going to simplify now, substitute change of x, will substitute this one, so that is 0. So we have now 2x plus 0. It will give you that is the same as 2x. Okay, 2x, meaning if the 2x now is the slope. Okay, so that is the slope. Okay, slope of the tangent line. Okay, so that is the slope of the tangent line based from the function, or this one, f of x is equal to x raised to 2. But it says in here, what is the slope of the tangent line at point 2? Okay, at point 2, at point negative 1 and 2. So what is the slope? Using this point of tangency now to get the slope of the tangent line, you can say now that the slope of the tangent line is what? 2 multiplied by what is your x? Your x is negative 1. Okay? So, meaning, our slope now will be negative 2. Okay? So, the slope now is negative 2. Now, what is that negative 2? Again, that negative 2 is the slope. Slope of the tangent line at point of tangency. Okay? At point of tangency. Meaning to say, this slope is the slope of this tangent line. So, the slope is negative 2. Okay? And that negative 2 is also the slope of the curve at a certain point, which is called now to be the point of tangency. Okay? So, I repeat, at a certain point that is called to be the point of tangency. So, negative 2 is the slope of the tangent line. At the same time, the slope of the curve at the point of tangency. Okay? At the point of tangency. I hope you understand. Thank you.